Okay, so in this lesson, we're going to continue talking about simplifying rational expressions, but notice that the focus here is on the idea of opposite factors. So if you go back to our previous two lessons that we looked at, the first, this was our first lesson, and this was part two. So that's the one where we worked out multiple examples on simplifying rational expressions. But if you go back to those two lessons, you will notice that not at one point did we talk about the word opposite. Nowhere when I divided common factors, none of those were opposites. They were the same. When I reduced, when I divided out same factors. Okay? We never talked about opposites. Well, there are situations where when you simplify rational expressions, some of those factors are opposites. They're not identical. So if they're not identical, you will not be able to just say 1, 1. You can't just cross them out and say 1, 1 if they're not identical. These are, so that's why you're able to say uh, uh, when you divide a factor by itself, you get 1. Okay? Now let's talk about the idea of opposites though. So before we do any examples, let's kind of review what opposites are. Okay, so the easiest thing you may remember is this. So this is a review of opposites. So you all know that 7 and negative 7 are opposites of each other. All right, so we know that's easy to understand. Opposite of each other. Okay? So that means that means also that if I were to divide two numbers that were opposites of each other, so in other words, if I said negative 7 divided by 7, I would get negative 1, right? Okay? Now, I can also, I want you to look at it this way as well. So negative 7 divided by 7. So also, if I reduce this, they both have 7 as a common factor. So listen carefully. So 7 divided by 7 is 1. Negative 7 divided by 7 is negative 1, right? And so negative 1 divided by 1 is 1. Okay? So that will lead us to this idea. So what if I had 8 divided by 8? Those are not opposites. Those are identical, right? Those are identical factors. 8 divided by 8 is 1. 8 divided by 8 is 1. Okay? So that kind of has that same connotation here. 2i minus 7 is 1. 2i minus 7 is 1. Those are not opposites. Those are identical. These are not opposites. These are identical. So notice 1, 1. These are opposites. Notice when I cross them out what I put in their place. 1 and a what? Negative 1. Because negative 1 divided by 1 is a negative 1. Okay, not 1, negative 1. All right? Okay, so that's the idea we're gonna use when we talk about opposites. So when you divide opposites, one factor is 1, the other one's negative 1. Makes sense. Makes sense because look, negative 10 divided by positive 10. When I reduce, 10 and 10 is 1. 10 and negative 10 is negative 1. 1, negative 1. Okay? So when you divide opposites, one factor is going to end up being a negative 1, and the other factor is going to be a positive 1. So keep that in mind. Okay, now let's look at this idea. So here's the question. What is the opposite? What is the opposite of, let's say A, what's the opposite of 6? Well, you all know the answer is what? The answer is negative 6. What is the opposite of 3x? Well, the answer is negative 3x, right? What's the opposite of a negative 4x? Well, the answer is 4x. Okay? Kind of makes sense, right? So these monomials here, that's easy to deal with. All right, but what about this? What if I had a binomial, like let's say x minus 5? What's the opposite of x minus 5? Well, let's think about this. So if you look at 6, to get the opposite, all you do is change the sign. 6 became what? Negative 6. If you look at 3x, all you did was change the sign. 3x became what? Negative 3x. If you look at negative 4x, you change the sign. Negative 4x became what? 4x. So those are opposites. So here you have two terms. So you just take the opposite of each one. So what? So the answer is the opposite of negative x. The opposite of positive x is negative x. The opposite of negative 5 is positive 5. So the opposite of x minus 5, you just change the signs, is negative x plus 5. But I want you to understand this also. This can be important when we go through our problems. Y'all agree that negative x plus 5 is the same thing as saying 5 minus x, so just reordering it. Okay? So the opposite of x minus 5 is negative x plus 5, or you can write as 5 minus x. Okay, now I want you to notice something else. Okay, listen carefully. Listen carefully. So do you remember that when we look at 7 and negative 7, so 7, see they're both 7s, right? Okay, if I want to be opposites, then this one's going to be positive, this one's going to be negative, right? Okay, so I want you to think about this as well. So listen carefully. So if we know the opposite of x minus 5 is 5 minus x. Y'all agree? Or negative x plus 5, doesn't matter. Okay? Because that means this. Okay, that means this. So if I look at negative x plus 5 and I factor out the negative 1, I factor out a negative 1 from x minus 5, negative 1 times x is a negative x, and a negative 1 times a negative 5 is a positive 5. Do y'all see that this right here is this? So the opposite, so if I want to find the opposite of x minus 5, all I got to do is multiply by negative 1. That's all I got to do. And so when you multiply by negative 1, you're changing the signs. And that's what we said here. All we do is change the signs. X becomes negative x. Negative 5 becomes positive 5. Because if I want to find the opposite of 6, I just multiply by negative 1. 6 times negative 1 is negative 6. If I want to find the opposite of 3x, I multiply by negative 1. 3x times negative 1 is negative 3x. If I multiply negative 4x by negative 1, I found its opposite. If I multiply this by negative 1, negative 1 times x is negative x. Negative 1 times negative 5 is positive 5. And so that's what this says. So if I want to find the opposite of x minus 5, I take x minus 5 and multiply by negative 1. And so that will give us one of these. Okay? All right, so that's going to be an important topic. Now, listen carefully to this then. Okay? What is, if I say reduce, x minus 5 divided by 5 minus x. What do you think that is? It's not 1, right? Because those are not identical. But what do you notice about x minus 5 and 5 minus x? And that's where we need to start thinking now. So we know that those are opposites. That's what we just talked about, right? So those are opposites. So that means this. So that means that if I use this idea right here, if I look at the denominator, and it doesn't matter, I can look at the numerator or denominator. It does not matter. But if I look at the denominator, I'm going to leave the numerator alone. And if I factor out, since those are opposites, that means I can take one of these and factor out a negative 1. And when I factor out a negative 1, what is negative 1 times what is 5? Well, negative 5. A negative 1 times what's a negative x? A positive x, right? And do y'all see that these two, even though you may not see it at first, but look at it carefully. Are those two right here the same? Yes, they are. So that means I can rewrite the one that's in parentheses as this. Negative 5 plus x is the same as x minus 5. And then those divide out. And so notice that I get 1 divided by negative 1. And so that's what our discussion was here. So if you have two things that are opposites and you divide those out, one factor is a positive 1, the other factor is a negative 1. If you divide two numbers that are opposites, one factor is a positive 1, the other factor is a negative 1. Those are opposites, right? So when I divide those out, one factor is a positive 1, the other factor is a what? Negative 1. And what's 1 divided by negative 1? Negative 1. Okay? So whenever you divide two factors whenever you divide two factors that are opposites of each other, their quotient is going to be a negative 1. So one factor is a positive 1. When you divide those out, the other factor is a negative 1. And and it makes you understand that based on what we just did here. Okay? All right, so let's look at some examples. Okay, so number 1, so this is going to be simplified. Number 1. So let's suppose we had 3 minus y times y minus 3. Okay? Now remember, the first step is to factor, right? First step is to factor. Can I factor anything here? No, the GCF is 1, the GCF is 1. Then you ask yourself, are any factors identical? Nope, there are no factors that are identical. But you may notice, but look, it looks like those are opposites of each other. So just check. So you have 3 minus y. In order for this to be the opposite, the signs have to be different. This is a 3, this is a what? Negative 3. This is a negative y, this is a what? Positive y. So yes, they are opposites. Okay? They are opposites. So what that means is this. What that means is that they differ by a factor of negative 1. So I'm going to go ahead and leave the numerator as it is, and I'm going to factor out the negative 1 from the denominator. And so negative 1 times what is a positive y? Well, a negative y. A negative 1 times what's a negative 3? Well, positive 3. And I want you to see, do y'all see that those two are the same? If you don't, watch it this way, and I think you may see it now. So negative 1 times, isn't negative y plus 3 the same as 3 minus y? Now you see those are the same. So these divide out, and you get 1 divided by negative 1, which is a negative 1. Okay? Now that's the thought process you go through, right? Okay, but here's what I want you to think about now, because you want to be a little bit efficient with some of this. So I want you to think about this. So if you have two factors that are opposites of each other, okay, and you're dividing them, then when you divide them out, one factor is positive, the other factor is what? Negative. One factor is positive, the other factor is negative. So what that means is this. If I go back and I look at the problem again, now this is what most students are going to end up doing. They're going to do this. All right, so they're going to say, well, I can't factor this, but I do notice that those are opposites. Okay, so that means I can reduce them. You can reduce opposites. You're just not going to have 1 over 1. You're going to have one factor being 1 and the other factor being what? Negative 1. And it didn't matter which one. This could be the positive one. This could be the negative one. Does not matter, right? Does not matter. Because look, if I go back, see where I took a negative 1 out of the, I factored out a negative 1 out of the numerator? I could have done this, 3 minus y divided by y minus 3, and I could have factored out from the numerator instead and left the denominator alone. So negative 1 times a negative 3 is a positive 3. A negative 1 times a positive y is a negative y. And those are identical because I can write negative 3 plus y as y minus 3, and that's the same thing down here. So again, it does not matter when you divide them out. When you divide opposites, it does not matter whether the numerator is negative 1 or the denominator is negative 1. It does not matter. But the point I want you to see is that when you rewrite your answer, a negative 1 divided by 1 is a negative 1. Okay? All right, let's do number 2. Number 2, we have 6y minus 42 divided by 7 minus y. Okay? All right, so if you look at the numerator, you can factor out a 6, right? So I'm going to factor out a 6, and I get 6 times y minus 7 divided by 7 minus y. So that's where I'm at. Now, that's about as far as I can go in terms of factoring for right now, although I could, if I want to, factor out a negative 1, but I'm not going to do that. I'm just going to leave it like this for right now, and I'm going to ask you, I have a factor of 6. Can that reduce anything down here? No. My next factor is y minus 7. Do you see a y minus 7 occurring as a factor down there? No, you don't. There's no identical y minus 7. But what do you notice about these two factors? They are opposites. They are opposites. So we are dealing with opposites. So that means this. If you were to do this work here, if you were to do all this work, what you would end up with is that when you divide those, one's a positive 1, and what's the other? A negative 1. And so therefore the answer is going to be 6 times negative 1, which is negative 6, over 1, and so you get negative 6. That's the way you want to approach it. Now, if right now you want to do the whole work, you want to do the whole thing, then this is what you would do. Okay, watch what you would do. You'd say 6y minus 42 divided by 7 minus y. You factor out the 6, just like this. And what I would do is, since I already have two factors up here, I would just factor out the negative 1 from here. So this becomes 6 times y minus 7 divided by negative 1 times, so you factor out a negative 1 out of here. So negative 1 times a negative 7 is a positive 7. A negative 1 times a positive y is a negative y. And I want you to notice that those two are the same. And so now 6 times 1 is 6. A negative 1 times 1 is a negative 1. And notice you get negative 6. Okay, so you get the same answer. All right, number 3. Number 3, let's suppose you had x squared minus 121 divided by 11 minus x. Okay, so in the numerator, that's a difference of two squares. So I can factor that as x minus 11 times x plus 11, right? Divided by, and then that's 11 minus x. Okay, so now let's see what I can do. So I have x minus 11. I don't see an x minus 11 down here. I see an x plus 11. I don't see an x plus 11. But let's go back to this one. Do you see anything that are opposites? Always look for that also. Opposites. Yes, those are opposites, right? So that means that when I reduce those, remember you cross them out. So that's why it was important when I told you earlier, when I mentioned earlier, that just don't cross them out. When you divide identical factors, you're left with ones as factors. So that thought process was important. I needed you to, every time when you divide common factors, you're left with factors of ones. Okay? So if you cross them out, you would not know what goes there. Something goes there. So since those are opposites, that means that this is going to be a positive 1, this is going to be a negative 1, because that's what opposites are. They differ by a factor of negative 1. Okay? And here's how you write the answer. So there are two ways to write the answer. So you can say negative 1 times x plus 11, just like that, divided by 1. I'm sorry, that's not going to be the answer, because I want you to remember that the numerator divided by 1 is just the numerator. So you could say this, okay? Unboxing the answer, or you can distribute. Now remember, we tend to leave the answers in factored form, so I would leave it like that. Or you can distribute negative x minus 11. Okay, so one of those is fine. Okay, number 4. So here's the thing I want you to get across, that when you divide opposites, if you recognize those are opposites, you don't have to do all this work. You can just say, well, if they're opposites, that means that when I divide those, the common factor, one's going to be a positive 1, the other going to be a negative 1. Okay, number 4. Let's suppose in number 4, we have 9 minus m divided by m squared minus 4m minus 45. Okay, so I'm going to leave 9 minus m as 9 minus m, and then in the denominator, it looks like I'm going to get m, one's positive, one's negative, and it looks like it's going to be a negative 9 and a positive 5. And always double check. 5 times negative 9 is negative 45. The outer is a negative 9m. The inner is a positive 5m. And I get a negative 4m, which is what you wanted. All right, so let's reduce. So what do you notice about these two? Those are opposites. So that means that when I divide those, again, don't just cross them out, because those are opposites, right? You are dealing with opposites. So that means that when I divide those out, this is going to be a factor of 1. This will be a factor of negative 1. And so therefore the answer is going to be negative 1 divided by m plus 5. Now, someone may say this. Someone may say, I want you to think about this. So let me go back and rewrite this little part here again, just to show you something. All right, so someone may say, well, if I divide those, do I have to make this one 1 and this one negative 1? No, you can make this one this negative 1. You can definitely do that. And so you would say 1 divided by negative 1 times n plus 5. So that's an answer. That could be an answer. Those do the same thing, okay? Because look, 1 divided by negative 1, 1 divided by negative 1 is negative 1, right? Or if you want to distribute, you can as well, just like we did in this problem here. So where we had negative 1 times the binomial, we just went ahead and distributed. So you could have done that here as well. So you could distribute 1 divided by negative m minus 5. So I just want to remind you of the different ways of writing the answer, okay? But what usually happens, just to let you know, what usually happens when you divide opposites, we tend, for the most part, we make the bottom, the factor that's in the denominator 1, and we make the factor that's in the numerator negative 1. That's what we tend to do. Just keep that in mind. The numerator is a negative 1 factor, and the denominator of the factor is a positive 1. Okay, number 5. Number 5, let's suppose we had this problem. We had 6t minus 18 divided by 3 minus t. So 6t minus 18 divided by 3 minus t. Okay, so let's go ahead and factor. So I get 6 times t minus 3 divided by 3 minus t. And now you got the hint. You know what to do. You know what to do. And so therefore, when we get to the harder problems, you will get it right away. So you know those are opposites. So I'm going to divide those out. Remember our discussion from here. We tend to make the factor in the denominator the positive 1 and the factor in the numerator the negative 1. So I'm going to put this as 1, this is negative 1, and notice the answer. 6 times negative 1 is a negative 6 over 1, which is just negative 6. Okay, number 6. Number 6, let's suppose we had 3k minus 15 divided by 35 minus 7k. So in the numerator, if I factor out the 3, I get 3 times k minus 5. The denominator, I can factor out as 7, so I get 7 times 5 minus k. What's the only two factors you can reduce? I can reduce those because those are opposites. So when I divide those like that, this one's positive 1, this one is what? Negative 1. And so the answer is going to be negative 3 divided by 7. That's your answer. Okay? Number 7. Number 7, we have y. Let's do this. Y squared minus 4y minus 12 divided by 6 minus y. So that's number 7. Okay, so if I factor the numerator, I'm going to get, let's see, I'm going to get y, 6 and 2, and the 6 will be negative and the 2 will be positive. And let's check it. Negative 6 times 2 is a negative 12. The outers are 2y, the inners are negative 6y, which gives me a negative 4y, divided by 6 minus y. All right, do you see any common factors? Well, kind of, right? I see opposites. I see factors that are opposites of each other, these two. So that means that when I divide those out, this is a 1, this is a negative 1. And so therefore the answer, see the denominator is 1, right? So it's just going to be the numerator. So therefore the answer is going to be negative 1 times y plus 2. Or if you want to distribute, you can, negative y minus 2. Okay? Number 8. Number 8, let's suppose we had, let's go ahead and do this one. 9 minus y squared divided by y squared minus 6y plus 9. Okay? All right, so the numerator, that's the difference of two squares. So I can get 3 minus y times 3 plus y. The denominator, I can factor as two binomials. In fact, that's a perfect square trinomial. So y, 3 minus minus, right? That's what this is. And do you see any factors that are identical? No, I don't see any that are identical, but I do see some that are opposites. So 3 minus y and what? Y minus 3. Now be careful. Either one of those, they're both y minus 3's, right? So 3 minus y and one of these, it does not matter. So again, it doesn't matter which one you use, does not matter. But when you divide those out, remember, those are opposites. So that means that one factor is a positive one and the other one has to be a what? negative 1. And so therefore the answer is going to be, and just leave it in factored form. So it'll be negative 1 times this, just like this, divided by y minus 3. Okay? Now, if for some reason, and usually what happens is that if this is a negative 1, students will go ahead and distribute, and you can, no big deal. I would just leave it in factored form, though. Then leave it like this. But you can write it as distribute the negative 1. You can get negative 3 minus y divided by y minus 3. Okay? All right, number 9. Number 9, we have, let's see, 3. We have x cubed y minus 5x cubed divided by 5x to the 4th minus x to the 4th y. So we have x cubed y minus 5x cubed divided by 5x to the 4th minus x to the 4th y. Okay, so for the numerator, it looks like I can factor out an x cubed. And so when I do that, I'm going to get y, x cubed times y minus 5. The denominator, it looks like I can factor out an x to the 4th, and I'm left with 5 minus y. That's a y. All right, now let's reduce. So notice that these are opposites. So right away, I know that this can be a factor 1, this will be a negative 1. I also know I can reduce the factors of x here. So I have 3 factors of x in the numerator, I have 4 in the denominator, so I can factor out 3. So this will be 1, and I'll have 1 factor of x left. And so therefore the answer is going to be 1 times negative 1 is negative 1, divided by x times 1 is x. Okay? So again, just remember, whenever you divide factors that are opposite of each other, we always tend to make the denominator of the factor 1 and the numerator of the factor of negative 1. Number 10, let's suppose we had 12 minus 3x divided by 3x squared minus 14x plus 8. So 12 minus 3x divided by 3x squared minus 14x plus 8. All right, so in the numerator, I can factor out a 3, so I get 3 times 4 minus x. The denominator, if I factor that, let's see what we get. 3x, x, and the possibilities for 8, let's try 4 and 2. The last sign's positive, so these signs are both going to be the same. They're both going to be negative. And it looks like the 4 is going to go here, the 2 is going to go there. So let's double check. The outer is negative 12x, the inner is a negative 2x, and I get negative 14x. And then notice, these are opposites, right? So when I reduce those, since they're opposites, the factor in the denominator is going to be a positive 1. The factor in the numerator is going to be a negative 1. And I can't reduce anything else. So I get 3 times negative 1 is a negative 3. 3x minus 2 times 1 is 3x minus 2. All right, number 11. Number 11, let's suppose we had 9 minus m squared divided by m minus 3 squared. So 9 minus m squared divided by m minus 3 squared. And so if I factor the numerator, that's the difference of 2 squares. And so I get 3 minus m times 3 plus m. The denominator is already factored, so it's just m minus 3 times itself, right? And then let's see, can I reduce anything? So I don't see anything that's identical, but I do notice that 3 minus m is the opposite of one of these. They're both the same, so let's just use this one. And so since those are opposites, remember, make one positive, one negative one. So let's do this one as a 1. This is a negative 1. And so the answer is going to be negative 1 times 3 plus m divided by m minus 3. All right. Number 12. Okay, the final one, I think. Yeah, that'll be the final one. So number 12, we have 10w minus 2w squared divided by w cubed minus 7w squared plus 10w. Okay? So in the numerator, I can factor out a 2w. So 2w times 5 minus w, is that correct? let's see, that's 10w, and then 2w times the negative w is negative 2w squared, divided by, in the denominator, and let me go ahead and kind of do that here. So I'm just going to rewrite the denominator. So now I'm going to factor out a w, so I get w times w squared minus 7w plus 10, right? And then let's see if I can factor this trinomial. So it's w times, let's see, w, last sign's positive, these signs are the same, both negative, and it looks like 5 and 2. All right, so that's going to go, that right here, those three factors are going to go here. So that's w times w minus 5 times w minus 2. Okay, now do you see any common factors, any factors that are identical? Yeah, you do, the w's, right? So those divide out. So remember, when you divide out exact factors, 1, 1. Now look for opposites. You see anything that are opposites? Yes, these two are opposites. 5 minus w, the opposite is w minus 5, because if you change the sign of 5, you get negative 5. If you change the sign of negative w, you get positive w. So that means, though, when you cross them out, one's a positive 1, the other one is a negative 1. And so therefore the answer, that's about all you can do. So therefore the answer will be 2 times 1 times negative 1 is negative 2. And then 1 times w minus 2 is w minus 2. Okay? Now just to let you know, now remember, that's what we tend to do, right? We tend to make if they're opposite, we tend to make the positive, the factor in the denominator the positive 1, and the factor in the numerator the negative 1. But if you did this, just to remind you, I'm just rewriting this original over. I just want to tell you what some of you are going to do. So you can divide these w's, so you get 1's in their place as factors of 1. And then you can say those are opposites. And so if you wanted to make this a negative 1 and this a positive 1, that is fine. No big deal. But remember, it's usually, this is what we do. Positive 1, negative 1. But if you did this, it's still fine. So you would have 2 times 1 is 2. So notice you would have 2 in the numerator instead of negative 2. But the negative would be in the denominator. So you would have 1 times negative 1 times w minus 2. So you'd have negative 1 times w minus 2. And I would just leave it like that. Leave it in factored form. So you see how this is really the same thing as this? It's just that here you put the negative 1 in the negative factor of 1 in the denominator, whereas over here was in the numerator. Okay? All right, so just keep those in mind. All right, so you know now that when simplifying rational expressions, it is possible for you to have opposite factors. And now you know what to do when you have opposite factors. So that's the end of this lesson.